Alright, so while I was off camera, I set up a rotovap so it'll be ready when we need it. And I made up some 1-to-1 ethyl acetate hexane. I basically just pipetted 3 mils of ethyl acetate and 3 milliliters of hexane into a 10 mil graduated cylinder, poured it into one of these, and then roughly equalized the volumes. It's a little uneven, there's a little more in that one. So that's the 1-to-1 ethyl acetate hexane mixture that we used as our TLC for the standards. And I'm going to run the same mixture so I know what the RFs should be. And I grabbed a UV light from the stockroom. So we can probably put 6 across. We didn't put 6 across before, we just put 3. But I think I can probably get 6 across on one of these. So with one plate, I can test that entire kind of middle row. So I'm going to mark the origin, and I'm going to put 6 little X's. And those are going to be fractions 3, 8, 13, 18, 23, and 28 that I'm going to put across that plate. And I can use the UV light to see what I'm doing as I add it. Oh, you'll notice, by the way, see this tryptamine, right? I said that the background would gradually fade. The tryptamine really shows the dark spots for the tryptamine, obviously, against the now much less dark background, because that's been sitting for a while. So I want a nice thin spotter, pretty thin on that end. Let's take a little bit of this fraction 3 and tap that on there. And I'm not expecting anything here, and I'm not seeing anything, so there's probably nothing in fraction 3. And go fraction 8. And it looks like maybe there's nothing in fraction 8. By fraction 13, I expect to see something, because the fraction 11 had that kind of whiskey ring. So as I spot that on there, you'll see that there's a nice dark spot. So fraction 13 definitely has compound. And then I'm going to go to fraction 18. My guess is it still has compound. And it does. Now whether that's the same compound or whether that's now the cinnamic acid coming off, we don't know. And then fraction 23. Looks like there's not a whole lot there, maybe a little bit. And then fraction 28. And if we're lucky, there's nothing in fraction 28 because it's all done. I probably can't use that anymore. So there's definitely some UV active spot in 13 and 18, maybe a little in 23, hard to tell on 28. The cinnamic acid wasn't as dark anyway. So now I can run that plate, and we'll see which spots we get, whether we get the different compounds in different fractions, which is what we want, or in the same fraction, which would mean the column didn't work very well. And while we're waiting, I'll go grab an iodine chamber, because we know that the vanillin stained nicely with iodine. So that's another way we can identify for sure where the vanillin is, and those iodine chambers have been moved. Apparently Dr. Prisner's lab is going to run TLC this week. So I don't think I'll need any of this stuff anymore. We'll find out. So we're just waiting for that TLC to develop. So since it looked like 8 was blank, right, and it looked like 13 had it, I'm going to want to TLC 9, 10, and 11, and 12 to see kind of where it starts to come off. And I already know I'm going to need that, so while I'm waiting for that one to develop, I can set another plate up where I put 9, 10, 11, 12 on a plate. the origin. I'll just go 4 spots across this time. So look at fractions 9, 10, 11, and 12. So I started with 1 there, which means that's 5, 6, 7, 8, so that's 9 here. And that looks pretty blank. And then we'll go 10. And there's definitely compound in 10. And then we can be pretty certain there's compound in 11 and 12 because we know it's in 13. So that's fraction 11. Fraction 12. Right, so 10, 11, and 12 clearly have some compound in them. And I can run that plate in the other chamber. So we run one just down the center row, 3, 8, 13, 18, 23, 28 to find approximately where it is. And then we run the edges to find out where it starts and where it stops. So we're just waiting for that to go up to about 1/2 inch from the top. Hopefully I won't need more spotters because I'm running out. I can always go pull some more, but you don't want to watch me do that. These spotters are made by taking an ordinary pipette, strongly heating the middle until it gets nice and soft, and then just yanking the ends apart. And the faster you pull, the thinner they get. So you can buy them, but they're expensive, and it's cheap to make your own from pipettes. You do have to be worried about the fact that hot glass and cold glass look the same, but they don't feel the same. So it's a little bit of a hazard. Hurt yourself if you're not careful. All right, so this silica is dry, right? There's no reason to waste it. I'm just going to pour it back into the silica jar so it can be used by someone else. Let's see. Yeah, that'll do. That's not as far up as I would normally let it run. But in this case, we're not really trying to get an accurate RF so much. We're just trying to find the compound. Shake that around to evaporate the solvent. And it looks like I've got a top spot here and here. Right, that's vanillin. And then I've got this traily spot here. That's probably the cinnamic acid. So it looks like fraction 13 actually has a mixture of vanillin and cinnamic acid. Fraction 18 has some vanillin, less cinnamic acid, and that's probably an artifact of when I washed the tip off, right? So some of the vanillin probably was up on the tip here, and I didn't wash it off until I got to one of the later fractions. So we need to see what happens in fractions 19, 20, 21, and 22 as well. I'll run another plate on those. So what we hope is that fractions 10, 11, and 12 don't have this yet, just have the vanillin. And I will stain that to confirm that that top spot is in fact the vanillin, because it stains with iodine, and that bottom streaky spot is the cinnamic acid. So we didn't get perfect separation, and part of that is probably because we had to use so much ether when we were loading it on the column. at origin here. I'm going to put 14, 15, 16, and 17 on there. And then I'm also going to put 19 and 20 to try to get an idea what's happening. I don't need to do 18 because I've already done 18. So 14 through 17 and then 19 and 20. And I'm going to make sure that doesn't go over the edge while I'm messing about with these other ones. So that was fractions 1 through 5, 6, 7, 8, 9, 10, 11, 12, 13. That's 14 there. I know there'll be compound, but I don't know which compound, or whether it's both. And then 15. And that isn't working because it didn't break off flat. And if it's not flat, then it doesn't come out. So there's 15, there's definitely something in it. And then 16 and 17. And I'm going to skip over 18. Have a look at 19 and 20. Must be a low fraction there. There we go. It's a small fraction. I have to tilt that to reach my spotter. This place should be about done. Solvent front pretty close to the front top there. And you can just switch plates. So I'll let that one run. Take a look and see what's in this one. There's 10, and there's 11, and there's 12, and those are very streaky. They look very much like cinnamic acid, not like vanillin, which is weird. Cinnamic acid has the lower RF, which means that, strictly speaking, cinnamic acid should not come off before the vanillin. And this may be a solubility issue. Cinnamic acid is a lot more soluble in our solvent than vanillin. So what we may find is that vanillin's not going down, but the cinnamic acid is dissolving in the PET ether and coming off early. Which may mean that this solvent mixture really isn't a very effective one. You'll see how crooked that developed too, right? This is why we generally run the co-spots, because when it develops that crooked, you can't get a really accurate RF. So I'm going to throw that in the iodine jar to confirm that that's cinnamic acid, not vanillin. It shouldn't stain. But you can tell by the shape of the spot and that stripe that we're seeing that it's the carboxylic acid, which sticks so tightly to silica. So I just have to get it so I can grab that plate. And as we expected, that top spot is the vanillin, and the bottom spot is the cinnamic acid. This one shouldn't stain at all. So we're getting an interesting artifact, which is that our more polar thing, the cinnamic acid, is actually coming off before our less polar thing, because of the solubility problems. Vanillin is quite soluble in diethyl ether and almost completely insoluble in petroleum ether, which renders column chromatography a little bit of a challenge. the people who reported this solvent mixture probably weren't trying to purify vanillin away from cinnamic acid. And maybe this isn't the ideal solvent mixture for doing that particular separation. There's definitely no vanillin in 28, and there doesn't seem to be any vanillin in 23. So what we kind of hope is that somewhere between 19 and 23, that's where that vanillin comes off. There's not much cinnamic acid in these fractions either, so that's a good thing. So I ran 19 and 20 on that plate. I'm clearly going to want to know what's going on in 21 and 22 as well. So I'll have to run another plate. Try to conserve plates as much as possible and not use any more than necessary, but I'm going to need to know. 6 across is about the most you can get. So 21, 22, I can skip 23, and then I'm going to go 24, 5, 26, and 27, so I can see what's going on there. Probably don't really need 24 through 27, but I got the plate, I might as well use it. So 21, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 30, right? 5, 10, 15, 20. So there's 21. Something in it, but not real dark. This one's a little thicker. 22. Skip 23 because I already have it.